All right, so we are moving into chapter 4. We will come back to the other chapters, but we're going to be talking about sampling and surveys. So we have 3 objectives today: to be able to identify the populations and the samples, to identify and explain good and bad sampling, and to obtain an SRS using technology or a table. So as we're working through the lesson, I want you to think about these 2 things. Why does a convenient sample have bias, and why does a voluntary sample have bias? So by the end of this lesson, these 5 questions should be something that you are able to answer. So go ahead and take a minute, look through them, see if you have any ideas about the answers yet. So this is a story that was actually in the news on Friday. So pause the video and just read through the summary that I wrote about what was happening. This is the actual story if you want to go to that website and learn about it. But go ahead and read through this, and then we're going to talk about it. So this is a picture I snapped, sorry, it's a little blurry, about this survey that they were talking about up here. And when we look at it, at the time that I snapped the picture, 94% thought the cheerleading split exercise was physically abusive, 5% said that it conditions young athletes, and 1% said they were not sure. So, we often use surveys to predict about the feelings of a population. Do you think that 94% of people in the viewing area agree that this is physically abusive? Do you have any questions about the reliability of the results? So, if I conduct a survey like this, where I ask viewers to go to a Facebook page or a Twitter page to vote, and viewers of the news, specifically WBIR, do you have any questions about the reliability of the results? So go ahead and pause the video and just think of a couple of questions that you might have. We are going to come back to this story. All right, this section is actually pretty heavy in vocabulary, so we are going to work through these vocabulary words throughout the course of this lesson. All right, so last year the stats class wanted to study student opinions about school lunch here at AE, and maybe some of you were interviewed. Asking every student was a daunting and time-consuming task, so they actually just interviewed about 60 students chosen at random in order to better understand how AE students feel about school lunches. So who is the population and who is the sample? So if you look down here, I've got our definitions. The population is the entire group of individuals that we want information about. We measure that with a parameter. So any number that describes a characteristic of a population, we call a parameter. And then a sample is a subset of individuals in that population from whom or which we actually collect the data. And we use a statistic to describe the characteristics of a sample. So essentially we have population sample, we measure a population with a parameter, and we measure a sample with a statistic. So in this case, who is the population and who is the sample? So if the population is the entire group of individuals, who are we trying to learn about? We are trying to learn about the students at AE. So that's my population. And so the sample is the 60 students that they chose at random in order to interview. So this visual over here talks about, so we have a population made up of all sorts of different people. We take a sample from that population, and we want that sample to best represent the population. And then I use the answers or the results from that sample to make an inference, which is just a prediction about a population or a conclusion about a population. So I have my population, I pull a sample, I try to make my sample look as close to the population as possible, and then I use the results to speak about the population. So in this case, we wanted to know about AE students and their opinions on lunch, so we pulled a sample of 60 students chosen at random, and we used what they say to begin to speak about how AE students feel about school lunch. All right, so in this scenario, I'm going to model how to pick out the population, the sample, the parameter, and the statistic. So last year, Austin East Juniors had an average ACT score of 14.4. A sample of seniors from our class showed an average ACT score of 17.4. So before we dive in, I want to clarify why we're talking about juniors and then taking a sample of seniors. So if I'm talking about last year's juniors are this year's seniors. All right, so the population. Who are we trying to predict about? And so the answer would be the Austin East seniors. We're talking about all Austin East seniors. And then what is my sample? So I pull my sample from the population. So if the population is Austin East seniors, my sample came from our class. So those students are being predicted to infer about the population. So the parameter. The parameter is a number that describes the population. So if the population is Austin East seniors and all of them, what is a number that describes them? Well, this number right here of 14.4, that was the average ACT score of the current seniors that they had last year. And then what is the statistic? And remember, the statistic is the number that describes the sample. So when I took the sample of seniors from our stats class, I found that our ACT score was 17.4. So the biggest thing to remember is thinking about what is the large group, what sample comes from that large group, and the way that I remember that a parameter describes the population is they both start with P, and a sample and a statistic both start with an S. Go ahead and pause the video and see if you can pick out the population, the sample, the parameter, and the statistic from this scenario. All right, so hopefully you were able to determine that the population is the seniors in Makebelieve County. That's who we're trying to gather information about. The parameter is 86%, so that's a number that describes the population. The sample is the 200 students from Mathis Cole High School, and the statistic is the 92% that came from that sample. So go ahead and pause the video and have an interaction because we have completed one of our objectives to be able to identify a population and a sample from a given scenario. All right, so how do we know if our sample best represents the population? And what would happen if I got a sample that didn't represent the population? And so I was using a statistic, that number describing the sample, to infer about the population, and it was inaccurate. What would that do? I want you to keep that in mind as we move through this next objective. All right, so just some background information. There are two distinct ways of collecting data. We can have a census, and a census is where we attempt to collect data from every individual in the entire population. So maybe you hear about the U.S. Census data that comes out every 10 years. There is an attempt to go to every single household in the United States and gather basic information in order for the government to understand the citizens of the United States. That is a huge undertaking that takes years and a lot of money and a lot of people to go out and survey each household. So a census is not always very realistic. So the other way to collect data is through a sample, which is studying a part in order to gain information about the whole. And that's what we talked about. I have a population, and I'm going to take a sample of that population and hope that they represent the population best so I can then infer about that population. So sample design is how I choose the sample from the population. And the big thing that we're going to talk about here is that poor designs produce misleading conclusions. So back to that question I just posed to you, what happens if my sample doesn't represent my population? So we're going to talk a lot about bias. And bias is what exists when the value for a sample is systematically different than the population value. So bias exists when my sample results do not accurately reflect the population. And there are multiple ways that I can have bias in my results, and we're going to look at those now. So Ms. Davis wants to know how many students at AE drive. She doesn't have a lot of time, so she decides to survey the first 20 people that come in the lunchroom during third lunch. She finds out that 75% of the people surveyed drive. She therefore concludes about 75% of AE students drive themselves to school. So, what is wrong with this design? So go ahead and just pause the video and see if you can identify some of the errors that Ms. Davis made or where there's kind of some information that might not be accurate. Because clearly 75% of our school does not drive. So the first thing that jumps out at me is that she doesn't have a lot of time, so she surveys the first 20 people in the lunchroom. All right, this is an example of convenient sampling. So I didn't have a lot of time, so I just grabbed the first 20 people I saw. That is a convenient sampling. And we're going to talk about why that creates bias. And it's an example of undercoverage. So the other thing that jumped out at me as a problem is it was during third lunch. So when I think about who is in third lunch, it's mostly performing arts students. And because it's the performing arts hallway. And most of the performing arts students are upperclassmen. The first lunch comes from students who are on the third floor. Well, who's on the third floor? It's mostly freshmen. So undercoverage is what's happening here as well, because not all members of the population being AE students, are being represented. So, convenient sample and undercoverage. Convenient sample is choosing individuals from a population who are easy to reach. So that was me grabbing the first 20 people in the lunchroom. And the bias can occur because they may not represent all of the members of the population. And that is a result of undercoverage, which is when members of a population are not represented in a sample. So generally, students in third lunch are not going to be freshmen. So that bias can occur because those not represented may have different answers than those who are represented. Probably most freshmen don't drive themselves to school, and that's why that number was a lot more elevated, was because we didn't have all members of the population being represented. If you had it to do all over again, would you have children? Ann Landers, who is a longtime advice columnist in the paper, asked parents this question. The overwhelming majority, 70%, who wrote in said no, kids were not worth it. So do you think that 70% of parents regret having kids? Well, probably not. So what is wrong with this design? So something that jumps out at me is that the overwhelming majority of those who wrote in. So when I think about people taking the time to write in, mail a survey response, click on a link and take the survey, the people who are going to be doing that are the people who have really strong opinions. And the people who have really strong opinions are the ones that are going to be heard. Whereas the people who don't necessarily have a strong opinion aren't going to take the time to go through the process of reaching out and becoming part of that sample. So this is an example of voluntary sampling bias. Voluntary response bias consists of people who choose themselves by responding to a general invitation. So the bias can occur because only people with strong opinions will usually respond. And that kind of goes back to when we talked at the beginning of the lesson about the WBIR survey, is the people who have really strong opinions and watch that video and are so offended by it are the ones who are going to go to the Twitter page, go to the Facebook page, and respond. So while most of us probably do think that it's a horrible thing, only people with really strong opinions are going to vote in, so that data might be skewed. All right, in this case, Mr. Langlois wants to survey the Austin East community to determine what issues they feel are the most important to the students at AE. He mails out the survey to a simple random sample of households in AE's zoned area and includes a self-addressed stamped envelope for the respondents to mail their responses back. So, a couple of things that he did that are good is a simple random sample. So I'm not just grabbing the first 20 people that drive through. They are households in AE's zoned areas, so the people who are getting the surveys are going to represent the population, which is Austin East community. The problem with this is he's going to mail out the survey and hope they mail it back. So this is an example of non-response sampling bias. Because even though he did the right thing in how he chose the people that were going to get the survey, the fact that they have to return it is probably going to result in some non-response. There's going to be some people who don't fill it out, even mail it in, maybe don't even get it. And so non-response sampling bias occurs here. And non-response bias is when individuals chosen to participate in a survey don't respond. Bias can occur because respondents can differ from the potential answers of those who do not respond. And there again, it kind of bleeds over into that voluntary response where people are choosing to be part of it. Even though we didn't choose the people who got the survey initially, they're still choosing to be part of the results. A statistician was asked to perform a quick study for a store in the mall to determine which type of Christmas decoration would be the most popular. The statistician makes a list of the different demographics that represent the customers of the store and stops to survey those that fit those demographics. All right, so one of the things that jumped out at me is that it was a quick study. And usually a quick study results in a convenient sample because I don't have a lot of time, so I'm just going to grab the first whatever people I see. However, the statistician did attempt to make sure that the sample or the people that were asked represented the population. So she made a list of the different demographics that represent the customers of the store. So the population would be the customers of the store, and she stops to survey those that fit those demographics. So she did attempt to combat some of that bias that a convenient sample can create by thinking of all the different people that might come in the store and then being sure to survey those that represent or fit those demographics. So we call this judgment sampling bias. So this isn't as bad as the others because we are taking into account the different representations of the population, but there still can be some bias that creeps in. So a judgment sample is using one's own judgment to select what seems like an appropriate sample. So she thought about the demographics and she went out and found people that fit those different demographics. However, bias still can occur because the sampler might have inadvertently left out a subgroup or may not find that subgroup. And the last one, a researcher is studying integrity in education for Knox County Schools and decides to survey a simple random sample of students from each Knox County high school. After asking questions like, have you ever cheated on an exam and have you ever plagiarized a paper, the researcher found that only 8% of Knox County students have ever shown academic dishonesty in their classes. So a few things that jumped out as positives in this is that they did a simple random sample, so everybody have an even amount of opportunity to be chosen, and they asked from each Knox County high school. So there wasn't any underrepresentation or undercoverage. Every type of high school student was being chosen or had an opportunity to share their opinion. The problem with this one, and this is what gets into the tricky part of statistics, is this is a really low number. And so we're talking about something of plagiarizing or cheating on an exam. So those are things that society has deemed inappropriate. So how many people do you think actually tell the truth when something that they're being asked about is socially unacceptable? So this is an example of response bias. Response bias is bias that drives an individual to respond in a way that makes them look more desirable to the experimenter rather than responding with the truth. So if a student was being asked by some researcher about, have you ever cheated, they're going to be more likely to lie because what they're being asked about, that response that's being elicited from them, is harder to be honest about. All right, so those are the different types of biases that exist in sampling. We're going to talk a lot more about it, but I'd like you to pause and think about those different biases, maybe draw a picture, write a connection to the scenario, have some sort of interaction so that when you see those words like response, undercoverage, convenience, those things, what do you know about those? What questions do you have? Go ahead and have an interaction now. So to avoid bias, we have to choose our sample by chance. We have to set it up so that each individual in the population has an equal opportunity to be chosen. So what is the best way to avoid bias when choosing your sample? It's going to be through a simple random sample. So simple random sample is a sample chosen in such a way that every group of individuals in the population has an equal chance of being selected. And we're going to talk about the 3 different ways to do a simple random sample. So I can essentially draw names from a hat. So putting every single person's name in the hat and choosing the 10 people that I want in my sample. I can use a computer or a calculator, and we're going to look at how our calculator can help us to randomly generate. And I can also do a table of random digits. So this is table B. In our book, it's going to be table D, but it's a random digits table, and we're going to talk about what that does. So to obtain an SRS, or a simple random sample, I need to make sure that every individual has the same opportunity to be chosen. So my first step is to label each individual with a distinct number from 1 to n being my largest amount. So when I think about our class, we have 24 students in our class, and I need to select 3 people to represent AE at a district forum. So I need to number them from 1 to n. Now the problem is I need to give them an even amount of digits. So if I only have 9 people, 1, 2, 3, 4, 5, 6, 7, 8, 9 are each 1 digit. But when I jump to 10, that gives me 2 digits. So when I think about 24 people, so I'm going all the way to n being 24 in this case, that's a 2-digit number. So I need to give everybody a 2-digit number. So how I'm going to do that is I'm going to start with Lexi, and I'm going to number her 1, but to make it 2 digits, I'm going to make it 0, 1. So then Angel will become 0, 2, Brandon 0, 3, so on and so forth. And once I assign everybody a digit, I can either randomize using Table D or technology. So using technology. So here's my list of everybody has been assigned a number, so everybody has an equal chance. And when you look at your calculator, you're going to go to the math button, and I'm going to arrow over until I get to probability, and I'm going to choose this random integer. And when I choose random integer, I need to tell the calculator I want to choose a random integer from 0, 1, because that's my smallest, comma, 24, because that's my largest. And then I'm going to hit enter, and it's going to kick out a number. I'll hit enter again, it'll kick out another number, and so on and so forth until I get the 3 people that I need. Now, a random digits table is the same concept, except for I'm going to choose a line, and sometimes it'll be assigned to you which line to choose, and sometimes you can choose. These are just random digits that exist in this line. So we are going to start with line 106. And so these are the numbers in line 106. And we are choosing from 2-digit numbers. So I'm going to go every 2 digits until I find the first 3 people that are selected. So I went ahead and divided it into sets of 2 digits because I'm looking for the first numbers 0, 1 through 24. And those are 2 digits wide. So 68 is not one of mine, so I move on. 41, there's nobody numbered 41, so I move on. And then I jump over, I use the 7 here and the 3 here. I don't have a 73rd person, move on. 50, 13, I do have a 13. So 13 is my first winner. Then I move on. 15, I do have a 15, so there's my second winner. 52, I don't have. 97, I don't have. 27, 65, 85, but I do have an 08. So the first 3 people chosen are Nick, Lavaney, and Tyreek. Now, I do want to caution you a couple of things when you're using a random digits table. Is if I had run across a 13 again, I throw that out and keep moving on because I'm trying to choose 3 different people. The other thing, if I had gotten to the end of this line and I still hadn't chosen my 3rd person, then I move on to my next line and I'd go through the same process. All right, that is our final objective for this lesson, to be able to obtain a simple random sample using either technology or a table. We will do more practice tomorrow and talk about these 3 objectives to make sure that they are set when you go to practice them. But go ahead and have an interaction. What do you need to remember about a simple random sample with technology or a table? What do you need? What questions do you have? Just have some sort of interaction in your notes. And then here are all of our vocabulary words on one page.